This is the second video for the assembly programming and reverse engineering course, and in this video I will talk about number systems, and I will start with the hexadecimal system. So the base of the hexadecimal system, that is 16. Later in this video you will see what that means. And in total the hexadecimal system is using 16 symbols, that's from 0 to 9 and from A to F. And hex 0 is in decimal also 0, hex 1 is in decimal also 1, and so on. It goes up to 9. Then we come to this area. So after 9 there comes the symbol A, B, C, D, E, and F. And A, hex A in decimal, that's 10, hex B, that's 11, and so on until max 15. So one number has a length of 4 bits. An opcode in assembly, for example, EB, that's in total 1 byte. And every single opcode has a max length of 1 byte. And opcode, that stands for operation code. An opcode is a hexadecimal representation of an assembly command, also just called a mnemonic. And maybe we can take a quick look. So you can just, if you in Windows, and just click on this symbol, then select programming, well, programmer. And now let's take a look at the first hex value, it's the E. Here we can see the binary number 1110, and later I will also show you how to calculate that manually. And here we can see we have 4 numbers, so 4 bits. If we type EB, then we can see that we have in total 8 bits, and 8 bits, that's 1 byte. Okay, then we can talk about the binary system. And the binary system, there are only 2 numbers, 1 and 0, and the base of the binary system, that is 1. And if you think about a circuit, then there are only 2 conditions, and that is on or off. On your main board and in the CPU, there are billions of transistors. These transistors are only the status on, and that is 1, or off, that is 0. And the computer is using logical operators to proceed complex tasks. And in the next video I will talk a little bit more about that. Binary to decimal. Let's take a look at this binary number. 11010110. And yeah, you need to read this number from right to left if we want to convert that to a decimal number. Okay, and yes, this is the last number. So we will start with this number, and this is where we will end. So the first value that we need to calculate is 0 times 1, that is 0. Then we take this value, 1 times 2 is 2. Then this one, 1 times 4 is 4. Then we have this value, 0 times 8 is 0. And 1 times 16 is 16. 0 times 32 is 0. And 1 times 64 is 64. And then 1 time 128, that's just 128. And then we can just add up all these numbers, and then we get this result. You can also type it in the calculator. So what is that? 11010110. And here you can see the end result is 214. But you can also use this method, and that is basically what you will find in all the documentations. So 0 times 2 to the power of 0, that's 0. 1 times 2 to the power of 1, that's 2, and so on. And then after that, just add up all these values, and then you will get the result of 214 again, and the base for the binary system, that is 2. Now maybe it's, you also know maybe why this is the base. So there are only 2 conditions, and yeah, here the red number, in this case that's the base. Okay, decimal to binary. How to calculate the rest of any number of the base is 2. Okay, if you have a value like 25 divided by 2, that's 12. So just ignore everything after the comma. Then calculate 12 times 2, that's 24. And then 25 minus 24, that's 1. And the rest is 1. So yeah, from 24 to 25, in this case it's just 1, and yeah, that's then called the rest. You can also use your Windows calculator and type 24 modulo or mod 2, and then you get 1. That's also in C, for example, the modulo operator. And so if you do something like this, 24% 2, and then that would also return the value 1. Okay, and so we can go over to the next example. In this case, now we will convert the decimal number 5 into a binary number. So 5 divided by 2, that is 2. 2 times 2, that is 4. 5 minus 4, that is 1. 2 times 2, 2 divided by 2, that's 1. And then the rest is 0, because 1 times 2, that is 2. So, and 2 minus 2 is 0. Then we have 1 divided by 2, that's 0, and the rest is 1. And okay, so we should call that one example 2. But it's just basically it's the same. So I don't know if we need to go through that. And yeah, final result. Oh yes, and there's one thing that we need to cover. So if we have calculated all the values, then you don't read from here. You don't read 1, 1, 0, 1. You need to read from the bottom up to the top. So that means 1, 0, 1, 1, and that is then we get the final result. Okay, addition and subtraction in the binary system. Yeah, and I don't, if that is confusing, whatever, then just use your Windows calculator. Okay, example 1. In binary, 0 plus 0, that's 0. 0 plus 1 is 1. 1 plus 0 is 1. And 1 plus 1, that is 0. And the carry is 1. And that means we write 1, 0. And 1, 0 and decimal, that is 2. I will explain this block in the third example. Okay, now we have these two binary numbers, 1, 0, 0, 1 plus 0, 1, 1. And again, we need to read the numbers from left to right. 1 plus 1, that is 0. Carry is 1. What is a carry? 1 plus 1. So here we get the value 0. That's our result. And the 1, that is a carry. Okay, next value, 0 plus 1 plus the carry from the previous calculation. So the result is 0 and the carry is again 1. Then we calculate 1 plus 1 plus the carry, and the result is 0. Carry is 1. And now we need to read again the values from the bottom up to the top. So the first value is a 1. The second value is a 0. The third value is a 0, and the last value, that's also a 0. Okay, example 3. 1 plus 1, that is again 0, carry is 1. 1 plus the carry from the previous calculation, the result is 1. Carry is 1, and yeah, you can basically just remember this pattern. Yeah, I like to think about it like that. 1 plus 1 is 0, 0 plus 1, so plus this one. 1 plus 1, that is 0, and 0 plus 1 is 1, and then we have still another carry, so the final result is 11. Okay, and the last value is 1 plus 1 plus the carry, and the final result is, so we get here at first this 1 and the carry is 1, and the final result is 1, 1, 1, 0. Okay, this is the first one. Here's the second one, third one, and the final value, or the last value, that's 0. And the full result is 1110. Decimal to hexadecimal, and yeah, how to calculate the rest. In this case, it's, yeah, we just need to divide the decimal number by 16. Why 16? Because 16 is the base of the hexadecimal system, and this is basically exactly the same like we did in the binary calculation example for the rest. So yeah, I didn't think so that I need to explain this again. And yeah, of course you can also just use your calculator and the scientific mode. 12923 modulo 16, that's 11. You can also use a programmer mode. 12923 modulo 6. Oh no, that was not correct. 12923 modulo 16. That is 11. If you want to type a hex number, then just click yeah, on this word. So always make sure if you are using this programmer mode that you have selected the correct section. Okay, next one. Example 1. Okay, 12,923 divided by 16 is 807, rest is 11. And now we need to convert this decimal number into a hex number, and that is a B. And 807 divided by 16 is 50. Rest is 7, and the hex number or value, that's 7. 50 divided by 16 is 3, rest is 2, hex value is 2. 3 divided by 16 is 0, so if you get 0 from any of these calculations, then you know, yeah, that you are at the end and you have calculated all the required values. Okay, so 3 divided by 16 is 0, rest is 3, hex value is 3, and again, read the numbers from the bottom up to the top. First value is the 3, next one is 2, then 7, and then finally the B. And yeah, we divide always by 16 because 16 is the base of the hexadecimal system. And here's another example, but that is exactly the same. Yeah, so I don't think that I need to go over that again. Okay, hexadecimal to decimal. We have this hex number, and again, read from right to left. A 10, A in hex is a 10 decimal. So 10 times 1 is 10. Next value is 3. 3 times 16, that's 48. B. Now we need to convert the B into a decimal number. 11 times 256, that's 2816. And the next value is 2. 2 times 4096, that's 8192. And the last one is 1 times 65,536, and that's 65,536. Now take all these calculated values and add them up, and then you'll get the final result. And yeah, again, always multiply here by 16, because 16 is the base of the hexadecimal system. And the next example, that is again exactly the same. But you can also use this method. So we have the A converted to decimal. 10 times 16 to the power of 0 is 10. B converted to decimal, that's 11. 11 times 16 to the power of 1, that's 176. 12 to the power 12 times 16 to the power of 2 is 3072. And the final one, 13 times 16 to the power of 3 is 53,248. Again, sum up all the calculated values, and then you get the final result. Okay, binary to hexadecimal converts a binary number into decimal number, and then just converts a decimal number into hexadecimal. And then we have this one, hexadecimal to binary, converts a hexadecimal number into a decimal number, and then converts a decimal number into a binary number. And that was pretty annoying, but yeah, I think it makes sense to cover at least some basics, since this course is, yeah, it's for beginners. And yeah, in the next video then we will talk about the logical operators. After that, I think we will talk about registers, and after that then we can finally start to write our first assembly code. So see you in the next video.